In this video, I want to discuss exponent rules, introduce you to those, and talk about scientific notation. So exponents are nothing more than an abbreviation. There's no profound idea there. It's just somebody got lazy writing a lot of stuff out, so they made an abbreviation. So if you have something, let's say to the fourth power, that's just a short way to write a multiplication with four parts that are the same, like that. All right. And so what we're going to do for the next few videos is we're going to discover patterns for certain expressions involving exponents. All right. What if you have two powers multiplied together? What if you're dividing a power by a power? What if you have a power raised to an exponent? All those we're going to discuss. All right. What I want to talk about for the rest of this video is I want to talk about the scientific notation and why is it useful. So a lot of times in science and in math you will be dealing with either ungodly big numbers or ungodly small numbers. All right, so for example, suppose you had this number. Imagine that you were doing a calculation on a couple pieces of paper and you had to keep writing this number out all the time. I think you would agree that it would get annoying writing all the zeros. What about also, that's a big number, what if you had to write this number a couple 10, 20 times? Okay, I think you would agree that that would get annoying, dragging all those zeros around as well. So what we're going to talk about is we're going to talk about how to see that the first one can be written as a small number between 1 and 10, 1.23 in that case, times 10 to the 11. Okay, that's a much easier thing to write. All right, and the second one can be written 4.56, again a number between 1 and 10, times 10 to the minus 10. All right, and that's much nicer to write. So I want to help you to be able to see how to do that. Okay, so we know that when we raise 10 to a natural number, that it simply gives us another power of 10, or excuse me, it gives you a number that's 1 with the same number of zeros as the exponent. Okay, you may also know that if you raise 10 to a negative integer, it's the same as moving the decimal to the left a few hops. All right, and that's going to be the key to how we're going to figure this out. So for the first one, remember that we want a number between 1 and 10. So the decimal, when we started out on the first one, the decimal, let me draw in red where the decimal is at on the first one. So it's right here. See that red dot? Okay, but what we actually want is we want the decimal to be between the 1 and the 2. Okay, how many hops is there between the both of those? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see that? Now it's because there's 11 hops or jumps, skips, whatever you want to call it, between those two decimal positions. That's a way to remember that the exponent has to be 11 for this case. All right? On the bottom one, same idea. We want the exponent to be between the 4 and the 5. Okay? And it's starting out over here on the far left. So again, let's see how many hops it takes to go from between those two red dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's tens. Now, in this case, notice that I move to the left. If you move to the left, then you're going to get a negative exponent. Okay? You don't necessarily need to get too hung up on which direction are you moving. Here's an easy way to think of it. If you have a really small number, then you're going to need a negative exponent to make a small number. If you have a really big number, you're going to need a positive exponent. Positive exponents make big numbers. Okay, I wouldn't get too hung up on this right or left. If you really wanted to do it that way, you start from your destination and move back to where the original decimal point position was, and see what direction that is. Okay, so there you have it. Okay, so let's end this video with some examples for you to do, some exercises. So try to put these into scientific notation. Okay, so you can pause the video and try these right now if you like. So for the first one, 1, 2, 3, so 8.76 times 10 to the 3. The second one, 1, 2, so 2.4 times 10 to the minus 2, and the negative just comes along for the ride. So I did the second example just to show you that you can't have scientific notation with negative numbers. It just means that your answer is negative, of course. Alright, so count how many hops and you'll be just fine. Now, you could, on the first one, you could have done this. You could have done 876 times 10 to the 1, or even 87.6 times 10 to the 2. Now, both of those would have been equivalent, but they're not proper scientific notation. So let me repeat for the nth time. In order for it to be proper scientific notation, the number in front has to be between 1 and 10. Alright? Not including 10.